it 95%. But what's the downside of making it 95%? If I say I don't want to be 80% confident. I want to be right 95 out of 100 times. What do you got to change here to be 95% confident? What can you change? David, you're saying? Well, first of all, given the same sample size, well, you can increase the sample size to become more confident. But assuming you're stuck to a sample of 5 volunteers, oh my God. Okay, if you're stuck to 5 volunteers, you would then say, to be 95% confident, what happens to the picture? This becomes from here is 95%. What is this piece over here going to be? Instead of 10%, it's going to be 2.5%. Remember, 2.5 and 2.5 is missing 5%. And this is going to turn out to be, instead of being minus 1.28, it's going to be minus what? Because we did this last time. What was the Z number for 5%? Everybody should be looking at the notes like David is, not just staring at me. Negative 1.96, or if you don't have the notes, check it out on the Z table. So what's going to happen if this is a negative 196 in a formula? It's going to make the interval bigger. So how do you end up being more confident? By basically saying my interval is like bigger from here to here, from here to here, from here to here. You're getting bigger intervals, which means you're being less precise. So you have a sort of a balance between being very precise. Obviously, you like to have a really tight, small, narrow confidence interval. But if that's the case, you could end up being not that confident. So if you end up being more confident, then you increase. So it's a trade-off between being very imprecise, but having a high degree of confidence in your answer, versus being more precise, but being less confident. You can't have it both ways. Now, well, there is one way. How can you have it both ways? What's the best? How can you get the best of both worlds? You want to be a nice, tight, small interval, and you want to get a very high degree of, like 99% confident. How can you get the best of both worlds? And we said it a second ago, but we have to repeat it. Yes. Yeah, instead of taking 5, you take 50 or 500 or 5,000. I mean, there's a limit to how much you can take, and the formula, you can see that from the formula. You just increase the n and whatever. So, but of course, again, to make life simple for these homeworks and this for Stat 1 class, we're basically assuming the sample size is fixed. But if you were doing this in real life, you would say, you know what? I'm not happy with being 80%. I want to go to 95. But if you go to 95, the intervals get very big. I'm not happy with that either. So you say, you know what? Something got to give here. Can I change the x bar? No, the x bar is the result of my sample. Can I change the sigma? No, that's the z. I mean, that's the result of the percentage of confidence. Can I change the sigma? No, that's given to me. Okay? So what can I change? I can only change the n. I'm making the n instead of 5, make it 35, 50, 100, whatever it takes. You can do it by trial and error. There are tables to help you figure it out, software. But the point is, you have control over that in real life to some extent. You don't really always have control over it because, for example, let's say you're doing a new drug that you're trying to test. And you can only get 5 volunteers to take the drug. You can't get a 500 volunteers. You can get 5 volunteers. So you're stuck with the 5. So you can do what you got. You know, got to do with what you got to do. But